The last example I'd like to look at today in this set of problems has to do with combining terms on one side of the equal sign. You'll often hear this in mathematics referred to as combining like terms. When the pictures come out, the process usually gets a bit easier for students to see. This will be reflected on some of the other problems that you'll be working with. So for example, say we have the problem x minus 3 plus 10 is equal to 8. And we want to solve that. So let's move and start talking about this visually. And take the image that represents and draw it. I have an unknown quantity in a box. So there's my unknown quantity x. I'm going to make that box just a wee bit bigger to represent that it really could hold any number of circles. Now, it says I'm going to be subtracting 3. So I want to draw 3 circles. 1, 2, 3. And I'm going to put a minus sign in them. It also says I'm going to be adding 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Now I have 10 plus circles. I'm going to be balancing this with a total of 8 discs. So here's my out of balance. 1, 2, 3, 4, 5, 6, 7, 8. Now, when I look at that, these 3 negative circles are going to cancel out 3 of those positive circles. When positive and negative meet, they cancel. So what's going to happen on this side of the equation, I'm still going to have my big box x with an unknown in it. I'm going to knock out 3 of those. So these are going to cancel, these are going to cancel, these are going to cancel. That's going to leave me 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7 positive circles on this side of the balance. On this side of the balance, what I'm going to find is I still have my initial 8 circles. And the scale is balanced. Algebraically, what I'm doing in this picture is I'm showing that negative 3 plus 10 is going to leave me 7. We call that, again in mathematics, combining like terms. Now that I've combined my like terms, I can go a step further. I know algebraically I can subtract 7 from both sides. Now notice the difference. I did not add 3 to both sides or subtract 10. I didn't subtract 3 from, I didn't do plus 3 plus 10. What I did was I merged these 2 quantities together simply by canceling what I'm seeing over here in the picture. So now I have this. I'm now left with x is equal to 1. So that means if I look at my picture, if I were to knock out 7 of these from this side and knock out 7 from over here, what's left? So I take 1 out, 2 out, 3 out, 4 out, 5 out, 6 out, 7 out. I'm left with 1. So visually, x is going to balance with 1 disk. What I do, I subtracted 7 from both sides. And I can see that there. My last step is to check my answer. So I'm going to plug this back in. 1 minus 3 plus 10 does that equal 8? Well, 1 minus 3 is negative 2, plus 10 is going to put me at 8. 8 equals 8. It checks out. Or, when x equals 1, the equation, and that equation is x minus 3 plus 10 equals 8, is true. Last but not least, I can draw a sketch of this. By taking this picture up here, I'm going to work up in here. If I were to put a single plus sign in that box, I can see visually that I now have this plus and these minuses are going to balance out to have 8 circles positive on this side and 8 positive circles on that side. And again, it checks out. The visual is meant to represent what's happening algebraically and combines with what we did last time to add the words. All right, your assignment tonight involves taking these equations and providing a good picture to go with it. What we're going to work on next is continuing to make these equations more and more complicated and use more and more of these pictures to help illustrate what it is we're trying to accomplish.